Good morning, everybody, to our discussion on scaling, symmetry, transformations. We started this discussion last time, but there are more transformations to do. Now, let me maybe write them down again. I have to just open application here. It's certainly not necessary to write everything down again, but it's something to look at. Because it's important to have a big picture of all the things that we should be able to do, see them in list form. It's good. I'm just talking while I'm waiting for this to open. There we go. Okay. Excuse me. All right. So let's maybe see where we are from start to finish. We had level 0, I think I called it, where in our Euclidean construction topic, we were allowed to use only these two constructions. Let's say here, draw a straight line. I'll say here between 2 points. It could be through 2 points or a line segment, doesn't matter. Then we were allowed to draw a circle or a circular arc, depending if you're doing it by hand or with software. You might have limitations like we did. Given a center point and a radius in different forms, but still. Let's fix this S a little bit. I could have another point that specifies my radius. Maybe I want to specify the radius or whatever, right? Those were our two. Then we said, my writing is this laggy today. There is a level 1 construction. I just made this up. I decided to make it level 1, right? You could call it whatever. But they help us on our way to bigger constructions. Let's remember what they were. I might mix up the order because I'm going on memory, but essentially we did these four. The perpendicular bisector. So that is given a line segment. I want to cut it in half with a perpendicular line. And we saw that this was the main one that we used for constructing polygons inside a circle, as well as the circumscribing of a circle around a regular polygon or a triangle. Then I also did a perpendicular line. I'll say here to a given line. Maybe through a point I think we had a line and then a point, and we wanted to draw a perpendicular line down. And we really just had to do a little construction to get us back to the first one. Then we did uh, bisecting an angle because there was this one was needed when we construct the when we inscribe a circle inside a regular polygon or a triangle. We need to bisect the angle, and then where those lines cross or intersect, that's our in center, right? So we needed that, and we do that over and over and again. So these are sort of more complicated than the basic constructions, but we use them repeatedly in fancier construction. And then lastly, uh, we made a parallel line to a given line. So especially the second one and the fourth one, they haven't really been used. Why did I include them? Well, when we get to transformations, they do come up. They do come up. So I want to, at the same time, make this fairly user-friendly. For example, I'll show you with GeoGebra. If you don't have GeoGebra, well, then it might be that we don't have any shortcuts. I just want to check on my screen that I've maximized my window here. That seems good enough. So I can look at, for example, let's take the very first one, perpendicular bisector, right? You've done that so many times now. It's definitely something that we want to remember if we don't already. I'm given the line segment. There it is. Boom. I want to cut that in half. Why did I put it so high? I don't really know. Let's center it. I have my construction to do that. Uh, I want to go to my compass tool. Oopsie, what did I just do? Compass tool, where are you? Compass tool. Let's make this bigger. No, not compass tool, right? I need to pick a point over halfway. From A over halfway, let's say over there. Then I'll go to my compass tool, make a circle centered at A, and then copy that circle to the other side. That gives me my 2 points, called D and E in this example, and we have our line when we connect those two, perpendicular and cutting the original line AB in half. Perfect, we've done that many, many times. Should be second nature. Someone wakes you up in the middle of the night, asks you to draw a perpendicular line to a line segment. You do it without really thinking because you've done it too many times. I'm not saying stop thinking, always think, but some things sort of become automatic with repetition. So there's nothing wrong with that. We have done it. It's on our list. We can always do it, right? But something like GeoGebra has the advantage that it has these level 1 constructions built in. Under the construct category, there is a perpendicular bisector tool that is going to do this, but in one go. So we can certainly have some quality of life tools to save us a little bit of time. For example, I don't know if I can go back far enough. Back, 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 back. There we go. There's our original line segment. I can do the construction. I just did it. And if that was the question, I should show my work to do that. Definitely. But if it's part of a bigger construction, then I can use this tool to just streamline it a little bit because it's not the end goal. It's a step on the way to a larger goal. Some quality of life, time saving tools. So when I click on it, it says select 2 points or one segment. Oh, I have a line segment there. Boom. Selected, perpendicular line. Done. And it is doing that construction that we just did previously in the background, not showing the work, yes. So I have these shortcuts because I have done it in detail, I've practiced it, I'm now allowed to use a shortcut, just like arithmetic. You learn how to add numbers, maybe up to 2 digits in your head. You have the development, you have the skill. Then later on, when high school comes around, you use a calculator just to speed things up because you have learned it already. You don't have to reinvent the wheel every single time. Okay. So we have done it for all of these. We can do the same thing for all of these. Let's just run through them. Perpendicular line to a given line. You'll see here in my, where is it now? Construct options. I have perpendicular line tool, which would require a point and a perpendicular line. So for example, if I backtrack here, I want a perpendicular line to this line segment, but I want it to go through that point. It's not going to bisect it anymore, right? We know how to do it. You draw your circle, you get 2 points for which this would be a bisector, and you go about your business. We've done all that. I can shortcut that with my perpendicular line tool, select a point, select a line segment, boom, perpendicular line. Right? Because I've done it, I can make things a little bit more user friendly. Okay. Next one, bisecting an angle. It's right there, angle bisector. I need 3 points because that's going to make my line, right? Let's take the line segment here. Let's make another point. Let's say over there. Let's connect them. And by doing that, we have created our angle. We know how to do this. Draw a circle, get 2 points, draw 2 more circles, and there it gives me a point, and that would be the bisector. We've done all that. It's just quality of life to make things a little bit more tolerable and streamlined. Select 3 points or 2 lines. I have 2 lines there. Boom, boom, bisector. Now in its construction, it also draws a perpendicular line to that bisecting line. I don't need that. Hide it if you want to. Whatever, I just ignore that. It does more than I want it to do. There's the bisector line there. Last one, parallel line to a given line. Oh, I have my parallel lines right. My parallel line tool right there. Let's suppose I have this line, my parallel line tool. Now I remember how to do that. I did it. Let's say I have another point, right? I need another point. Let's say over there. You connect them, you copy the angle, you copy it over here because parallel lines will make the same angle with an intersecting line. We've done all that. Easy peasy. Just quality of life, streamline it, select a point and a parallel line. That's my point, that's my parallel line, boom. It's doing all of that in the background for me. If this is a stepping stone towards a larger or as part of a larger construction, I don't want to get bogged down with this. If the question in a test asks me specifically, draw a parallel line to a given line through a point, yes, then I have to do my circles because then I am stuck with my level 0 constructions. So a higher level construction can use lower level constructions or the same level. And that can be done in a more convenient way. So now I'm not going to write that down, but we did level 2 constructions on top of this, where we need some of these, mainly the perpendicular bisector and the angle bisector, over and over and over and over and over. We did that. In those, I want to show some detail, but because we've done it so many times, we can streamline it using Geogebra because those tools are built in. So I don't get bogged down. I remember the steps on a higher level. Same thing now happens when I do my, so I'll say here level 2. We've done previously polygons in a circle. We've done circumscribing a circle, circumscribe, circle. We've done inscribing a circle. We've done all that. And I'll put that at level 2. Whoa, what just happened there? Something fun happened there. In addition to that, also at level 2, we have our transformations. That was supposed to be an A. Transformations. And we've done one of them already. We've done the scaling one. Scaling. Where we needed to measure our line. That was the main extra tool that, sure, technically isn't listed, but we use this distance or length measure, as well as measuring or drawing a circle with a predefined radius, and we already did that. So you can watch that video if you don't remember that at all. Let's move on to the other ones. What's the next one? I'm just going on memory. I want to do them in the same order as the book. What was the next one? Why can I not remember? It doesn't really matter what the order is. We can maybe do a translation. The other one's a rotation. I want to do the rotation last. And then, what is this other one? I want to scale it. Oh, reflection. Right. We'll do that third. Wow, it's blacked out there. Reflection and rotation. Whoopsie. There's no particular order of these, but we did this one, scaling, great. And we use some tools to make our life easier. The measuring tools, pretty much. Translation. Let's do it. So I start with some polygon, some shape. I'm not going to make things overly complicated. A triangle will be more than sufficient. Let's just close the polygon there. So I want to translate this so that my new point A, it needs to specify which point should move to this new position D. Just let's say the top one. So this is my new position for A, or we call it the image of A. I transform it. A will be over here. B is going to be somewhere over here, and C is going to be somewhere over there in their transformed positions. I don't know where. Okay, so that's what I start with. I have my original shape. I have a reference point for where to shift this to. How do we do it? First off, we draw a line connecting A and its counterpart, D in this case. All we need to do is super simple. We need to draw lines parallel to this AD through B and through C. Now, yes, again, I can go old school and do detailed level 1 construction 4. But we've done that. We know how to do it. So for the purposes of just streamlining this, I will use the parallel line tool, where I need to select a point, which will be B, and then a line to which it should be parallel, and there we go. Again, if the question asks, show your work to draw a parallel line, that could be a separate question, right? So I don't get too clogged up with detail in this higher level construction. I want to do the same through C, to the original line, all parallel. It's doing the things in the background for me so I can focus on this new construction. All right, that is the first step. Next step, I want to measure the distance from A to D. That is how far I'm going to shift my triangle. Translation just means shifting it. Shift. It's the fancy word is translation. So this tells me I need to shift it 6.8 units. I'm then going to measure from B a distance 6.8 units. I do that by drawing a circle and specifying its radius. So the center radius tool, center should be B. What should your radius be? 6.8. And that gives me a point, which will be the new position of B. I might want to hide this circle. Now this circle is necessary in this higher level construction, right? Because I needed to copy a distance, and that's the only way I can do it given these tools. Well, not really, but I don't want to do the line segment. I like the circle. You can use the segment with a given length as well, but I prefer the circle. So it's visually a little nicer. Anyway, then I can measure this length and confirm, oh, 6.8, good, good. Exactly what it should be. Then I want to do the same thing. Just want to check, can people hear me now? I missed the chat. Can we just have a check that you can hear me? Checking my audio. On my end, it looks good, but I didn't respond to this time. Was there a section where you couldn't hear anything, or did the whole actual lecture work? I had the wrong, I didn't have main classroom chat open. I had the course chat open by accident. Because no one else really said anything or no private messages occurred, so. Okay, so it wasn't a big deal. Okay. Okay, good, good. Okay, so I need to do the same thing going from C along its parallel line. I'll use my circle with a specific radius, centered at C. It's going to be 6.8, of course. And that gives me a point over there. And then I can maybe hide this circle if you want to. Oh, let's measure the distance to show that label and confirm they're all the same. That's nice because visually I can't quite see. Oh, this is 6.8. No, let's measure it and be sure. Then I'll make my polygon by just connecting the corresponding points, and I have the exact same triangle just shifted over to the position that they want. All right. So the steps involved aren't super complicated, especially when I have tools to streamline existing lower level constructions. I know how to do the detail of all these level 1 constructions. If I need to use them over and over and over, let's save ourselves some time and headache by just not shortcutting this, just streamlining it. There is still some work I can show. I've measured, I've confirmed the lengths here. I show how I get the distances. I've showed some work, right? It's more than sufficient. Just save some time and makes it a little bit easier. All right, so that is the next one, a translation or a shift. And it's sufficient to just work with a triangle. If I had a larger polygon, I just have to do the same things more often. Doesn't really show any insight. Reflection is next. So here they have to give me some shape. Let's stick with our triangle. Why not? If I can do it 3 times, I can do it 4 or 5 times as well as a line, let's say like that. The 2 points are automatically just given so that the line is unique, right? Those points don't play into this construction. They're just the side effect of the tool that I'm using in GeoGebra. I want to reflect this triangle in the given line. So I want to create a mirror image on the other side. How do I do that? All I need to do is draw a perpendicular line from each of the vertices through the given line. I know how to do that in detail, right? Let me run through it to refresh your memory. You make a circle. Let's pick a point. Let's pick a point over here. And I'll use my compass tool. This is now showing the detail through that point like so. Whoopsie, confirm, center it there. That gives me another point where that circle intersects. And then a perpendicular line from A to the line will bisect this FG segment. Now I have a line segment and I want to draw a perpendicular bisector, which means I need a point, let's say from G over halfway. Actually need that circle all the time. Over halfway, use my compass to draw a circle centered at G, copy it over to F. That gives me 2 points. Boom, boom. And I'll draw a line through them all, of course going through A as well, perpendicular. I know the detail. I don't have to always do the detail in this higher level construction. So let's go back. There we go. That's where we were. I need to draw a perpendicular line from point A to this through line DE. I have that tool, perpendicular line tool, where I select the point, I select the line. It's all done for me. Again, I can only use the tool because I know how it is done. I don't want to use a tool that I don't understand. Then I'll do the same thing from B, same thing from C. These do give me new points where these lines intersect the reflection line. I want to label them because I need to measure their distance. Now, I can measure the distance, if for nothing else, to show the label on my work. But if I measure AF as 4.1, I don't have to. I have a couple of options. I can go back to my circle with center and radius because I want to measure the same distance on the other side. That's where the new point A will sit. Center, my radius, I forgot what it was. Cancel that. Cancel. Uh, 4.1. So I'll do that again. I can specify 4.1, and that'll give me my point on the other side. Now, because this is rounded, I might be a little off. It doesn't look like it's perfectly going through A, because this might have been 4.08, but the presentation, the label rounds it to 1 decimal. So that might not be the best idea. I don't need to know what the actual length is. I do want to show the label eventually. I can just use my compass tool and say I want to make a center, I want to make a circle with center F and radius FA. And now it's perfect. That length is automatically determined as the radius of my circle, and I get a point on the other side. So I just want to copy the lengths AF, or the length from my vertex to the reflection line as accurately as possible. I can then make a label by measuring this distance. Yes, it says 4.1. Who knows if that's a little rounded, but I show, oh, it's the same. So the compass tool I feel is more accurate. I might not want to see it for my next one because I need to now copy the distance from B to the reflection line over to the other side. Compass tool will get the job done by just drawing a circle centered at G out to B. No, other way around. Get rid of it. Get rid of it. Centered, outside into the center. There we go. That gives me another point over there. That'll be my new point B. I can show that the distances are the same. I might not want to see the circle right away. While I'm working with point C, I now want to do that one more time with my compass tool, make a circle centered at H, and that'll give me the point at the same distance on the other side. I can show the distances to show my work. Yes, oh no, move that guy, it's right in my way. Show the length there, A to K. Of course, it's right in my way again. Geogebra allows me to move it very quickly. I might want to gray out that circle because it was sort of background work, but I do want to show, in the end, everything. Almost done. I just have to finish this new polygon by connecting the corresponding points, and you can very easily visually verify that it does look like the reflected version, the mirror image of the original. So that is how we're going to do a reflection. I need a line, the reflection line. Then I'm simply going to draw perpendicular lines down to it, measure the distance, copy the distance. Circle is a little bit more accurate. Copy the distances to that line over to the other side, reconnect the polygon, and there it is. All right. And again, I can shortcut constructions in a lower level, in this case, the perpendicular line to a given point, because I have already figured that out. Then it's okay. Then it's okay. So that is that one done. And again, like I've said many times before, make your own, write down your own steps in your own words. Don't try and conform to the book. It doesn't know you. Maybe you like to say things in a different way. Maybe you like to add a step in between two steps in the book to help you follow. It's all good. Make your own steps. Don't read the book in this case. Look at the video, write down your own steps, and see if you can duplicate it. Last one is rotation. Now, admittedly, rotation is going to be, I guess, a little different in the sense that we don't necessarily have a level 1 tool, but we do need to be able to measure an angle because we're going to start with a polygon. Let's put it over here. Triangle is sufficient. We're going to start with another point. Let's put the point over there. And we want to rotate this shape, rotate this polygon around point D by a certain number of degrees in a certain direction as well. Let's say clockwise, because that's where my space is. But of course, if it was the other way around, I could just move things over here and rotate it the other way around, right? Doesn't matter. So I need to specify an angle. So let's go 120 degrees. So I'll put that in the chat so we can remember. and let's say clockwise. That's our goal. It needs to specify the sort of the center of that rotation, and it needs to tell me by how much do I rotate it and in which direction. So for that, we're going to, I think a line segment is sufficient. Let's start with point C. Just make a line segment to the center. Now, if you're doing it by hand, you have a protractor that can measure an angle. You lay it on top of this, you measure the angle, you mark off a point. Of course, we don't have a tool in quite the same way, but we do have some measuring tools. I'm not measuring a distance or a length, but it is in the same category. It is an angle with a given size. So then if I click on this, it says select a leg point. Oops, click on it again, vertex, and then enter the side. So the first thing I select is the outside, away from the center, which will be point C, then the center, and then the size of the angle that I want to rotate. In our case, 120 degrees. I want to pick clockwise because that's what the question says. So take care of which direction the question wants. I say OK, and it's moving this point C for me to a new point C, which is called C prime. This little dash, the image of C, the new position of C. Okay. To make it look nice, I like to have a line segment there, but it's totally optional. It's not necessary. If you do it by hand, it is kind of necessary. But this just looks a little nicer. It sort of feels more connected to me personally. Personal choice. The tool does a lot for me, this angle with a given size, in that it moves the point right away for me. If you're doing it by hand, you can measure the 120 degrees, but it might not be the right distance away. Maybe your compass, your protractor is really big, you put a point over here, then you need to draw a line and measure this distance DC, so it's the same as that one. So it's important maybe to measure this length and show that the center of the rotation to my vertex is the same as the center of the rotation to my new vertex. Okay, so I want to show these labels as well, because by hand it might not be as immediate as it is on this application with this tool. I want to show this distance has to be the same. So C prime is the new position of C. Now I'm going to do the exact same thing for, let's say, A. I'll make a line segment there. Now, yeah, I don't think I actually have to, but I think I definitely want to see a line segment there, because if I do it by hand, I have to have a line there. Then I'll go to my measure an angle with a given size. Select my leg point, which is the top A. Select the center, specify 120, it remembers. Just remember to pick clockwise, and it rotates it for me to the right position and length. I just want to add some stuff to show that these distances are what they should be. So I pick my distance or length tool and just label the distance from A to D, and then D to the new point A to show, oh, they're both 7.2. So everything is good. And then we do the same thing for B. I need to rotate B, make a line segment to the center of the rotation, pick my angle with a given size, outside point, center point, specify the angle, specify the rotation direction, and there's my new point for my transformed B. Want to connect them so that I can show the distances. B to the center, 5.1, new B to the center, 5.1. Everything is good. Last thing to do is just reconnect the new points of the polygon. Now visually it's a little bit more difficult for me. You see that this was rotated correctly in some cases. I suppose if I try and preserve this around this point D, it looks reasonable, right? But visually it's hard for me to assess that this is exactly where the rotated image should sit. It's a little bit harder for me to see. There's nothing to show and hide. We show everything we've done. The angle with a given size tool is quite convenient. It does a lot. It does a lot for me. Now I have to have a tool, just like I would have to have a protractor to measure an angle, so I can measure any angles. If I want to not rely on a tool like that and do it in the absolute basic way, then I'm stuck with manufacturing angles, and I can't easily manufacture all kinds of angles. For example, I could go and manufacture, I'll just do it on the side here. So let's move this a little bit. I could go and manufacture a 90-degree angle by just drawing a perpendicular bisector, perpendicular line. Let's say maybe there. Oh, I need an actual point, right? Not perpendicular line. Perpendicular bisector would be simpler. That's my diameter. Perpendicular bisector to this line is over there. So I've created an angle here of 90 degrees. And I can then copy that angle over here, but it's very cumbersome and tedious. I can create a 45-degree angle and therefore also a 135-degree angle by bisecting the angle that I have as 90. Just make a point there. So I can sort of go back to basics and not artificially, and systematically create angles. There I've created a 45-degree angle there that I can copy if the question wants me to use that angle, or a bigger 135-degree angle. But creating any angle, it's not always going to be really practically possible. So to not limit myself by that, I use this much fancier angle with a given size, which is sort of the equivalent of the protractor in your geometry set. Oops, did we lose our polygon? Back too far. There we go. So don't worry about creating angles by going back to lower levels. That is a little bit too cumbersome, tedious, and unnecessary for us. Unnecessary. Okay. So we have 7 minutes. I want to do another rotation, one that people often struggle with a little bit. But these are our 4 transformations. We are technically done. Understand what you have to work with to perform this higher level construction. But a question could also just ask to show how do you bisect an angle, for example. Then you can't use that tool. You have to use level 0 constructions to do this. But when it's a higher level, like in level 2, all our fancier constructions, and I need to do anything lower level, I can use a tool and speed up and make my life a little bit easier. Okay, so understand what we're allowed to do and when. I just want to do another rotation. I know it's not the most complicated. If my, like this maybe, if my point of rotation is in the middle, inside my polygon, zoom in a little bit. People often struggle a little bit and get confused, but the method doesn't change. Just the appearance is going to be different. Let's pick point A. Actually, I'm going to pick point C again. Draw a line from the center or connecting the 2 points. Oh, let's pick an angle. Let's pick a small one this time. Let's rotate by, I don't know, 30 degrees. Rotate by 30 degrees. Let's do counterclockwise. Let's do counterclockwise 30 degrees, just to mix it up. Now I'm going to mainly use my angle with a given size tool. The rest is just for display purposes to make it look pretty. I pick my leg vertex, then the center of the rotation. I'm going to pick 30 degrees. Counterclockwise is already selected. Good to go. There's my new image, the image of my point. I'll connect them because it looks nice. And I want to show that the distances are the same as they should be. So I'll measure D to C, D to C prime. Yep, it's the same. Good job. These labels are never going to be in a good position because I don't have a lot of space here. So if they overlap, if they hide some stuff, it's okay as long as it's not too crucial. Then I'm going to do the same thing to point A. Let's make a line segment there and then specify the angle that I want for the rotation. It remembers everything's good, 30 degrees counterclockwise, go. I don't like this line, this point just floating around. I want to connect it to the center. Personal choice, I suppose. Our tools don't depend on it. And then I want to show a label for the 2 points. For the first line segment, as well as the second one, show, yep, they're the same. Good job, keep going. Now do the same thing for B. Make a line segment from the center of the rotation out to B. Measure an angle. I know I don't need that line, but by hand I would need that line. Leg vertex, center, rotation is still the same because it remembers. It gives me my new point, the image. I just connect them so that I can measure from D to B, 4.4, D to B prime, 4.4. Okay, good. Then the last thing to do is make the new polygon, A prime, B prime, C prime, A prime. It's a little on top of each other, but it looks kind of nice. Looks kind of nice when I look at the end. It's a pretty picture. People feel, especially when I did the scaling transformation as well. Sometimes the point that they give me, the center point is outside. Sometimes the center point is inside the polygon. And people feel that, oh, I need to do different things because it looks so different. It's the same thing. Same thing. Don't let the look of it fool you. That is the end of all things. No. All things geometry constructions, I suppose. Lots to practice. They're all built on each other. Obviously, it's obvious to me, but I'll say it anyway. Obviously, don't even start with level 2 constructions. If you are not perfectly comfortable with level 1 constructions, obviously. Obviously, don't bother with level 1 if I don't understand what I'm allowed to use in level 0. Now, level 0 doesn't have much of a construction. You draw 2 points, you connect them with a line. Great. But it does give you the time to familiarize yourself with the tools you're allowed to use at that stage, at that level. Master level 1 before you move on. People don't listen. People don't do it. They rush to those problems. They go. And then they're confused when things don't work out. Well, you didn't really build up your understanding and your skills in the uh, ideal way. So I can only advise you. All right. Are there any questions about this? Any of these can be on a test, maybe more than one. Who knows? You don't know, so you have to prepare them all. Any thoughts at this time? No thoughts. Then we will continue this. Let me just see, where are we? I want to see what our schedule looks like because I don't remember exactly which day goes where. If we're ahead of schedule or behind schedule. We seem to be very much ahead of schedule. How did that happen? Oh, because the length and area scaling didn't need 2 lectures. We're actually ahead of schedule. Oh. Uh, I'll finish the last chapter tomorrow, and that'll make Friday a Q&A session. Or should we swap it around? No, let's just finish it. We'll finish, make Friday a Q&A session, and look at all these Q&A sessions that we have. Whew, too many. It's too many. People are going to complain we have too many catch-up sessions. Well, it's already in the schedule. But then there is no excuses to not have quiz 3 be very good. Please also note that there's been a slight update for next Friday, the 19th, and the following Monday. These 2 blocks are yellow, which means there won't be any live session. The video on these topics will be in our playlist. You watch them in your own time, work through them, pause, scroll back, scroll forward, whatever. Slow it down, speed it up, and then you can let me know if you have any questions on that. Sometimes self-paced learning is helpful. In a live session, you can't always ask your question when you want to. You want to just pause something, you just want to hear it again, and you can't always. So it's nice to sometimes just have a video to go at your own pace. But that's after quiz 3, so don't worry about that right now. All right, until next time.